Welcome back to another C-sharp episode, getting into object-oriented programming, and let's get right into it.
Polymorphism, a Greek word that means to have many forms. Objects can be identified by more than one type. An example of polymorphism can be a weapon that is considered as a sword. It can be considered a spear or a frying pan. A car can also be considered as a vehicle, transportation, or an object. A human can be considered as a policeman or an engineer or a librarian or a carpenter or a blonde or a brunette or just as a living organic being. So let's create some classes around some medieval RPG types. We'll create a class for weapon, and we'll create a public virtual void, which is something that can be taken on by other methods. So this one we're going to leave blank because this is a virtual method with nothing in it. It's going to be inherited by our other methods with polymorphism. So the way that we do that is pretty much by using inheritance. So the parent and child class creations. So let's create a class called sword, which we're going to inherit the weapons, fields, and methods. And we're going to use the suggested public override of attack. And we'll create a write line sword slash. A sword slashes when it attacks. Now we can create a spear, which is also a weapon. And we'll do console write line a spear thrusts. Then we'll do a class frying pan, which is also a weapon if you use it as one. And with the frying pan, you can whack someone with it. So now that we have our three weapons created and inherited from our class weapon, we can invoke their methods here with sword. We'll create a new sword here. We'll create a spear here. And we'll create a frying pan. And for each weapon, we'll create an array. Sword, spear, frying pan. And we'll do a simple for each. So for each weapon, in weapons, we'll do weapon.attack. So this will cycle through all of their attack moves in this array. So it's going to go through each item in the array, and for each item, it's going to use its method. And the methods are going to be displayed differently depending on the fields of the objects. So if we run this program, it says sword slash, spear thrust, frying pan whack. Let's talk about interfaces. Interface is just like a parent class that you can create child classes from, like the one that we just did in the previous example with the different weapons. It's kind of the same thing. However, with the interface, it creates rules that the child classes need to follow when inheriting. So the difference between an interface parent and just a standard class parent is that the class parent doesn't create rules on the child, whereas an interface parent is just like a class parent, but it's just a bit more strict. So the interface declares what a class should have. An interface decides how a class should do the actions that it does, the methods. And the benefit to this is it increases security. It's better for multiple inheritance. It creates templates and blueprints. so that when you start replicating these, you don't start messing them up. It's kind of like scalability and infrastructure as code when it comes to the DevOps world. If you're familiar with Terraform or ARM templates, you know the importance when you have big scale corporations and infrastructures. You want to make sure that every time you deploy something, it deploys exactly the same as all the other things that have been deployed in that infrastructure already. You don't want to be open to human mistakes or the mistake of something being different and not working. So there's also a sense of stability when building your classes and objects with interfaces rather than just standard classes. So let's build out our interfaces. Beforehand, we would create a partner class like this. We do class organic life, let's say, and then if we were to have a class that inherited it, we would just do human organic life. And that's how we had it before. However, when you're creating interfaces, all you have to do is change class to interface. And as you can see, this reads it as the same thing. So our first one, we're going to have organic life. And this is our parent class. This is our child class inheriting the rules, methods, and fields of our organic life. So we're going to create a new method here called void lives. So organic life, it lives. And a human, we'll do public void lives. And it can create a customized console write line. The human breathes, eats, lives, and codes in C# and sleeps. And now we can create another interface for mechanical entity. Void, and mechanical entities don't live, but they compute. So it computes. And for mechanical entity, we can create a class robot, which is a mechanical entity. Public void computes. Console write line. The robot will destroy all humans. We can create a cat too. So a cat would be organic life. And it would live and purrs, eats, meows, sleeps, and lives. And we can also create one that inherits a little bit of both. So we could do class cyborg, which can be organic life and also a mechanical entity. And in here we can create two different methods. So we can do public void lives and write line. The cyborg is half human, thus still has sentience, emotion, and desire. The cyborg also computes. The cyborg is half robot, thus exceeds the physical and mental capacity of humans. So now we've got two interfaces, which are the parent objects. We've got organic life that lives, mechanical entity that computes. We have a human, which is organic life, and the humans breathe, eats, lives, codes in C# and sleeps. We have a robot, which is a mechanical entity, which will destroy all humans. And we have a cat, which is organic life, and the cat purrs, eats, meows, sleeps, and lives. And then we have a cyborg, which is one of two worlds. It's organic life and a mechanical entity. And the cyborg is half human, thus still has sentience, emotion, and desire. The cyborg is half robot, thus exceeds the physical and mental capacity of humans. So if we want to run a program with all of these, like a game or something, then we do human, and then the human name and new human. We can name our human as well. I can name mine Randall, and we can create a robot. I'll name it Bender, and we can create a cat. Oh, I forgot to capitalize my cat and my cyborg. Our cat can be Zeus, new cat, and we have our cyborg, which is Arnold, new cyborg, and now we can do Randall lives. The robot computes. Oh, sorry, Bender computes. And Zeus lives. Arnold computes. And Arnold lives. So now if we were to run our console app, we're now referencing the human with Randall, the robot with Bender, the cat with Zeus, and Arnold writes both of these lines. Now let's talk lists. Lists are data structures that represents a list of objects that can be accessed by index. They're similar to an array, but it's scalable. That means you can increase and decrease them in size. You can do it dynamically and statically. It also uses a system.collections.generic. So that would be put up here at the top. You don't have to add it because it's going to automatically use it if you're using Visual Community like I am. So let's start off by creating an array. Just a quick refresher of what an array is. So we got a spell, and it's going to be a new string of, let's say, 3 items in the array, or 4 items. That's actually how it is. So we do spell 0 equals, let's say we got fireball, spell 1 equals hailstorm, spell 2 equals levitate, then we got spell 3 which equals heal, and our for each string item in spell we'll do console write item, and this is going to cycle through all the spells just to print everything out. And as you can see, we can't type all these out because we can only type out 3, because this signifies that we can only type out, there's only 3 items in our array. So if we add 4, it's going to error out. So arrays are pretty limited like this. So instead of doing it this way, we can delete this and just type list string spell a new list string. And instead of having this block like this, we're going to do spell.add fireball. So pretty similar to how we have it underneath it, but instead of having to specify what index in the array we want to add it to, we just put spell add. So we do spell add hailstorm, spell dot add levitate, and spell add heal. And in order to access an element in a list, you just type right line spell, and in a pair of brackets you specify what part of the list you want to access. So if I want to access the first element of fireball, I were to type in 0, hailstorm is 1, levitate is 2. So it's the exact same as an array when it comes to accessing the elements in the array. And now we can add and remove an unlimited amount of elements without having to change the construction of the array every time we want to make changes and updates. We can also do other manipulations, like we could do spell remove heal, which will remove the heal spell above here. We can do spell dot insert, and you put in, you could do this two ways. You could insert it by doing spell 2, or you could do insert 0 and do heal. Or can you do it that way? So this first option is going to insert into the first spot where fireball is. It's going to put spell 2 into where fireball is. So spell 2 is levitate. It's not going to replace fireball. Instead, what it's going to do is it's going to essentially look like this. So it's going to add levitate to 0 and push firewall up to the first slot. But we don't need to put that there. This is automatically doing that. Then this one underneath it is going to put heal at 1. Then it's going to push that levitate up 1. So this one now becomes 1. And then, you know, so it all gets pushed up like that. So insert doesn't replace, it just inserts. But we have console right line spell count. And this gives you the amount of spells that we have now. So if you print this out, it shows that we have 5 spells currently. And we could use index of for us to locate and this one's going to locate where levitate is in my list. So it shows that we've got levitate in the first part. So the first element is levitate. And we can add another instance of levitate. And we can write, now that we have duplicate instances of levitate, we can do spell which one is the last index of levitate. So now it can look through duplicates to check which one is the last instance of it. And this one shows the last instance of levitate is at 5. We can add a spell like firestorm, and we could do console.writeLine spell. We could check if spell contains firestorm, and it says true. It does contain the firestorm spell. We can also do spell.sort, which then, so the sort function sorts everything alphabetically. So if I were to create a couple new spells here, like spell add alteration, let's say, and then spell.add zealotry. And now if I were to compile this, we can see that alteration's at the top and zealotry's at the bottom. We can also do reverse. Which will then reverse our list alphabetically, putting Z at the top and A at the bottom. We also have spell clear, which just clears out the whole thing so it doesn't actually put any of it out. We can also convert our list into an array. And after converting it into an array, we can then do another for each loop. Where we can then go through each item in the array and print them all out. But it doesn't do that because we have clear activated. So let me and now you can see it goes through the whole array. Now let's do another list for players. If we had a video game online, we could have different players. So we can create a list called player and name it players, new list player. And then here we're going to do for each player in players. And our right line is going to display the player and the username. So as you can see, we don't have these classes created yet. So let's go ahead and create them. We'll do class player. And we'll do public string username. You know what, instead of class, let's do inherit interface. Let's get that inheritance going. We got the public string username, then we have public player string username, and we have this username equals username. And then we'll create a public override string to string method. Return username. So here comes a point that I was trying to show, where interfaces don't always have the same capabilities that classes do. Because interfaces cannot contain instance fields. So let's go ahead and change this back to a class. And now our object is working the way that we want it to. So now to get some players going, we can do some instantiating of player objects by doing player1 equals new player Hungarian nerd. And we're going to do player dot add player1. So now if we run our script here, we've got Hungarian nerd as our first player. So here is one way of instantiating our objects. There's another way to do this two-liner in one line. And the way that you would do that is by doing players.add new player Hungarian nerd. So these two lines do the same thing as this one line. So let's delete that. And let's add a couple more players here. Let's get young Nick and Daffy. So we got Hungarian nerd, young Nick, and Daffy. Those are our three players. And those players are created within our list. So instead of using an array for players, we used a list to create a list of elements that are players.